Hello, welcome to Kube's educational classes. And this is the class of standard 10th and subject is geometry. And I am Mrs. Padwalkar AR. So let us start your geometry class, and your first topic is of similarity. Okay, and in this first we are going to study some properties related to areas of triangle here. Okay, so see here. So first I will take two triangles. So here is one triangle. This is a triangle ABC, and this is a triangle, suppose PQR. Okay, so it is a triangle ABC and triangle PQR, and in that suppose AM is the height of this triangle, and as it is PQR triangle is a obtuse angle, so its height we can show here outside. So suppose PES is the height of this triangle. Okay, so see here, in this triangle ABC, AM is the height and BC is the base, and in triangle PQR, PS is the height and QR is the base. Okay, understood? So now we are going to study about the areas of these two triangles. Okay, so in general, what is the formula for area of any triangle? So it is what? Half into height into base, right? So area of any triangle is always half into height into base. So applying this formula in these two triangles, so what ratios you will get here? So see, area of triangle ABC. Okay, so it is area of triangle ABC I want to tell here. So it is what? Half, then height. Okay, but see children, what is the height? AM is the height, BC is the base. Remember that one. So according to that, what formula I will get here? Half into height. So height is AM and base is BC. Okay, so keep this as the equation number 1. And now same, take the area of triangle PQR. So there also it is half, and see here in this triangle PQR, PS is the height and QR is the base here. Okay, so half into height is PS into base is QR. So this is your equation 2. So suppose now if you want to divide this both equation, so what? Now equation means this is the left hand side, this is the right hand side. Here also LHS and RHS. So take the means divide this both equation, means we have to divide LHS to LHS, RHS to RHS. Okay, so as per that, so area of triangle ABC over area of triangle PQR, what you will get here? Half into AM into BC, because area of triangle ABC we have taken, so its area is this, and whole divided by half into PS into QR, right? So LHS to LHS we have divided, RHS to RHS we have divided. Okay, so now this half will get cancelled, and what you will get here? AM into BC over PS into QR, right? Means AM is what? Height. BC is what? Base. So height into base, and here also PS is the height and QR is the base. Means you got ratio of areas of any two triangle is equal to ratio of product of their corresponding base and height. Okay, so more clearly if I want to write here, so here is the statement that what is this first property we have seen? Ratio of areas of any two triangles with a different base and different height is always equal to ratio of product of their corresponding height and base here. Okay, and more clearly if I say, suppose there is a triangle 1 and triangle 2 is there. Okay, and triangle 1 has height h1 and base b1, and triangle 2 has height h2 and base b2. Then according to this above statement, how we will get the relation here? That is ratio of areas of any two triangle is equal to ratio of product of their corresponding heights and bases. So here this is a triangle 1, so h1 b1. Now triangle 2, so h2 b2. Okay, so remember, so this is the first property. What? If you want to take the ratio of areas of any two triangle which have different base and different height, then it is always equal to ratio of product of their corresponding heights and bases here. So according to that, this is your first property here. Okay, now let us see second property, and for that also we are using the same figures. You remember that triangles which we have drawn here. In short, I will draw here. See, so this is triangle ABC, and we have taken triangle PQR, and AM is the height, and here PS is the height they have shown. Okay, so now suppose if heights are equal, both triangle have same height, that is length AM is equal to length PS if you have. Okay, or what we have considered this height H1 and base B1, here this height H2 and base B2. So that is now if we have H1 equal to H2. Okay, so just now what we got last in the first property, ratio of areas of any two triangle. That is, now here we can take triangle ABC over area of triangle PQR. Okay, then here see we can take now what, half to half. Then height is what here, AM, right, and base is what, BC, and same again here, half into height PS and base QR. Okay, half will cancel, and AM is also equal to PS, so this will also cancel. So what will remain here? Only BC over QR. So that is BC is the base, QR is also base. So a ratio of areas of these two triangles with a common height is always equal to ratio of their corresponding bases. Okay, so in short, if you want, you can write here base is what, B1, and here B2, like this you can write here. Okay, so in this way, this is the second property, ratios of areas of any two triangle with a common height is always equal to ratio of their corresponding bases. Now third one also same. Now suppose in the same triangle, now bases are equal, means B1 is equal to B2, or in figure what, now again this is ABC, AM is the height, BC is the base, right, H1 B1, and here PQR and PS is the height we have taken, right, and QR is the base, this is B2, this is H2. So now if bases are equal, means BC is equal to QR. If it is there, then what, ratio of area of triangle ABC and PQR. So what, according to the formula, half into height. Height is AM, base is BC. Half into height into base. Here half into height PS and base is QR. So half cancel. But now here see children, BC and QR are same. So they will also get cancelled. So equal to what you will get? AM over PS. So AM is the height of first triangle. PS is the height of second triangle. Means you got H1 over H2. Means what? Ratio of areas of any two triangle with common base is always equal to ratio of their corresponding heights. Okay, so in this way this statement also is written here. Ratios of areas of any two triangle with a common base is always equal to ratio of its corresponding heights. Okay, so more clearly in short I will tell you. See, what there are, we have taken two triangle ABC and P. Okay, we have taken obtuse angle triangle, right? So that same triangle I will take here, right? And this is P S Q R, and here this is we have taken M. So this is height, this is BC is a base, and here this is the height H2, and this QR is the base of this triangle. Okay, then see, if heights and bases are different, then what we can tell, this is, suppose this is triangle first ABC. So ratio of areas of any two triangle with a different height and different base, it will be what, B1 into H1 and B2 into H2. Okay, but if bases are equal, okay, means if B1 is equal to B2, then this ratio will become how? Yes, it is equal to height over height. And if heights are equal, then it will become B1 over B2. So ratios of areas of any two triangle with a common height is equal to ratio of their corresponding bases, and with a common base it is equal to ratio of their corresponding height, and if both are different, then it is equal to ratio of product of their corresponding heights and bases. Okay, so these are very three important properties are there, and depending on that your exercise 1.1 is there. Okay children, thank you.